Hello, Honored Algebra. Mr. Lawrence here with your flipped lesson for Wednesday, March 28th. Here, we'll start off with the answer key, but before we do that, I want to mention I was really impressed with third period on Tuesday. I'm recording this on Tuesday, so that's why the thought is fresh in my head. I was very impressed at how many of you were able to tell me what, the line x equals 5 looked like, or x equals 4. I don't remember the exact equation, but you did it without difficulty. Now, those of you having trouble, remember, lines are made of points. Find a few points that you know have to be on the line, and then draw it. Get those points plotted. All right, if x equals 5, then any point you write down, you better write 5 something. Okay, so here is the answer key from the second set of 9 word problems you had to do. All right, I'll scroll through them a little bit. I've given you the equation and the solution. All right. I'm going too fast. You can slow it down, pause at any time you need it. Make sure your equations are right. And, don't cheat yourself. Don't just write down my work. It doesn't do you any good. All right. And there we go. By the way, I would expect to see something like question 9 on the test on Friday. Definitely expect to see that. Okay, hold on one second. I want to save this so I don't lose it. Okay, I'm back with you, and we're going to talk about a couple more problems. Let's talk about that field goal problem kind of situation. And let's say we have, I don't know if your parents would remember, there was a local guest. Hold on one second. Back in the day, there was a local TV celebrity named Superhost. That's Gary Short, I think his name was. And he had a show called Superhost where they showed old movies and Three Stooges and things like that. And he had a character called the Moronic Woman. It was a spin-off of the Bionic Woman, which was an old TV show. And he showed one with her kicking a field goal, and her leg flies off and goes over through the goalpost. Anyway, the reason I tell you that is it's relevant because we are talking about kicking a football off the ground, and it was done at my junior high school. That was filmed at Greenbrier Junior High. In fact, Superhost came into my language arts class, I think in 7th grade, and said hello to us, and then said hello to us on TV, which was really cool. All right, we have a person kicking the football, and we know that the football is going to travel in a parabolic path, right? So it's going to do something like this with those cool sound effects, right? And we're only going to worry about the height. Let's see here. Hold on one second. Okay. We know the goalpost is approximately 11 feet off the ground, and we're going to say the initial velocity is going to be 5 feet per second. I want to know, will this ball go high enough? Will it go high enough to go 11 feet off the ground? Now the trick will be, what's the vertex? What is the vertex? If I could figure out the vertex, I'll know how high the ball goes, and then I could figure out if it's over 11 feet, it should clear the goalpost. Okay, we're not worrying about the distance away. Of course, that affects it too, but for Algebra 1, we're not going to go that involved. All right, so let's say we have the equation h equals negative 16 t squared plus minus v sub o t plus s, right? I've told you so many times, t is the time in seconds. V sub o is your original velocity or your initial velocity. We use a positive if the object is going up to begin with. We use a negative if it's going down to begin with. And this ball is being kicked up, so we will use the positive version. S is your starting height, and h is your ending height. Okay. Well, the first thing I'm going to do is I'm going to use this equation here, and I'm going to let the ending height be 0, negative 16 t squared, and my initial velocity is 5 feet per second. My starting height is 0 because it's being kicked off the ground. Okay, so I am going to go ahead and use the quadratic formula on this. Antara seventh grader asked me if I could factor, to solve this stuff. Absolutely. Unfortunately, this one doesn't factor, but if I could, like if, 5 was a perfect square or something like that, I could go ahead and do that. In fact, you know what? I could GCF this. It'll be kind of ugly, but I'll tell you what, I'll do that. I'm going to pull out a t. I'll use the quadratic formula in a second. I'm going to pull out a t, and then I'm going to have negative 16t plus 5. I know that this is going to be at t equals 0. That's my starting point. But I'll solve this one. And I'm going to go negative 16t plus 5 equals 0. Negative 16t equals negative 5. T will equal 5/16. That's going to be how long it takes, 5/16 to hit the ground again. So it's not going to take very long. It's not even going to take barely over a quarter of a second. It's not going to take very long. I'm suspecting that this ball is not going to go high enough. Now, I'm not going to use the whole quadratic formula on this. This work was just kind of a side note showing I could solve for t by factoring. Okay, so that's not really relevant to this problem. But I need the vertex. So I'm going to use t equal to negative b over 2a. That will give me the t coordinate of the vertex, the time at which the ball is at its highest point. Okay, and when I do that, I'm going to get 5 over 32, right? And it's not a coincidence that this number here is half of that number, right? 5/16 times 1/2 equals 5/32. If the ball is starting on the ground and returning to the ground, it makes sense that the vertex is going to happen at the midway point, doesn't it? If I have a coordinate system like this, and I have a parabola doing that, doesn't the vertex have to occur smack in the middle, right? At the median place? Okay, so I'm not surprised at that result. Now, to get how high it's going to go, I'm going to use this number here in this equation. And I'm going to let the height equal negative 16 5/32 squared plus 5 times 5/32. And for an ugly calculation like this, I'm just going to go to my graphing calculator, and it looks like I'm still in that program mode that we're working on. And I'm going to clear that out of the way, and I'm going to go with negative 16, and it's 5/32. And I'll square it, and I'll add 5 times 5/32. And there we go. It's not going very high at all. It's not even going a foot off the ground. Wow, it makes me feel like I did something wrong, but actually everything is right. 5 feet per second is not very high. In fact, let's test it. Maybe I'm feeling like I did something wrong, so I'll go to a graphing calculator. Negative 16t squared plus 5x, and I'll zoom 6 it, and look at that. Look at that. I'm going to do a Z-box around this one. I'm going to blow up the part around the origin. Look at this. This thing doesn't go anywhere. It's, like maybe when my 2-year-old son kicks it. What I'm doing is I'm blowing up the portion of the graph that I want to see the most of. And I'll hit trace, and there I'm at 0, 0 essentially. Okay, if I type 0. Okay, now I know the vertex was at what, 5/32? Yeah, 5 divided by 32. And there I am at the vertex, and see I'm at a tiny, it doesn't go anywhere near a foot. All right, let's see what happens. Let's play with that velocity and that initial velocity, v sub o, and let's double it. Let's make it 10. And let's see what happens here. Let's see what happens to the graph. Okay, I better do a zoom 6 on it so we can get a better, and it's still not going very high, is it? All right, let's make it 20. So now we've quadrupled the initial velocity. Now we're getting higher. Let's hit trace. And I know, well, I don't know actually, because I'd have to look at my equation. Let me see, the x-coordinate of the vertex will be negative 20 over 32. So I'm going to do 20 divided by 32. The negatives will cancel. And it's only going 6 1/4 feet. So even if I kick it at 20 feet per second squared, no, excuse me, 20 feet per second with the initial velocity, it's still not even going halfway up. Well, let me go and change it again. Let's make it 40. Oh, that's a good sign, because I know I was doing 10 by 10. Let me change this. Let me make the Y max, say let's make it 20. And let's see if we can, well, I can't get the whole graph in with 20, but that's a good sign because I know it's definitely going high enough. All right, let's change that equation, or excuse me, change my window. Now let's make the Y max, say, 30, counting by fives. So it's still not showing up. Let me make it 40. Oh, there we go. It's showing up. And you know what? The X min doesn't really need to be -10. I think I'll change it to -5. Okay. And the X max, it's hitting the ground pretty soon. I'll make it +5. And let me see what that graph looks like. Oh, that's looking pretty good. All right. Now, the equation, the x-coordinate or the t-coordinate of the vertex would be -40 over -32. So it would be 40 divided by 32. This is the place where the ball hits its maximum height. And it's at 1 1/4 seconds, it's going 25 feet in the air. All right, let's go back to the problem here. We'll use the graphing calculator in a second. So in this time, what V sub O was 40 feet per second, right? Did I get that right? Hold on. Yeah, V sub O is 40. Okay, it's still off the ground. And I want to know at what times will the ball be greater or higher than 11 feet. So when will the ball be higher than 11 feet? Okay, well, I've got my h equals -16 t squared plus v sub o t plus s. I know s is going to be 0, my starting height. Okay, so I won't even put a 0 in. I know the -16 t squared is going to be there. I know my initial velocity is 40 t. I want h to be 11, so I put the 11 in h's spot, the ending height. It's going to generate 2 times when h is 11. Now, I can't solve this in this form for the quadratic formula. I need this to be 0. Okay, and so I will get 0 equals -16 t squared plus 40t minus 11. Okay, and so A equals -16, B equals 40, C equals -11. So I'm going to solve for t, -40 plus or minus the square root of 40 squared minus 4 times A times C. I know that's going to be a negative because there's 3 negatives, and I'll divide that by -32. I'm just going to use one of my little tricks over here to simplify this. I'm going to do 16 doubled is 32 doubled is 64. And 64 times 11, it's going to end in 4. 6 plus 4 is 10. I'm going to carry the 1, and I'm going to get a 7 out front. You can verify that if you like. I'm pretty sure it's right. -40 plus or minus the square root of 1600 minus 704, and I'll divide that by -32. And at this point, I can go to my calculator. Maybe I'll do one more simplification here. -40 plus or minus, oh, let me see here, 700, it's going to be 900, it's going to be 896, I think. I'm feeling a little insecure about that. Let me just check my work, 896 and 704. I'm going to get a 0, I'm going to get a 0, I'm going to get a 16. Yeah, that's going to work. I wanted to start 1600. Okay, so now I'm going to go to my calculator. I got a 40, an 896, and a 32. So I'm going to clear out of this, negative 40 plus the square root of 896, and then I'm going to divide that by negative 32. Okay, so I think it's going to hit the first height at about a little bit less than a third of a second, 0.31 seconds. So let me do that. So I think t is going to be about 0.31, 31 hundredths of a second. Okay, so I'm guessing, and I'm gonna, not guessing, but I'm interpreting my data to mean this, that if the ball is kicked like this, okay, that this is 1, when I reach about a third of a second, that's going to be at 11 feet. That's what I'm saying, at 0.31. And of course, that's a rounded answer. Now, there's going to be a corresponding point over here with a different amount of time, right? And my quadratic formula is going to find that for me. So let me go find out what that is. And then I'm going to use the graphing calculator to check it. So I'm going to go second enter, and second enter again. And I'm going to make that a minus. Okay, and I'm going to divide by negative 32. And I'm going to get about 2.19, so 2 and 19 hundredths. So the other one, or 2 and 19 hundredths seconds, right? Okay, so I'm saying that this is about 219, approximately, and that's going to be at 11 feet as well. All right, so let me go back to my graphing calculator, get my graph up here, make sure my equation is the right one. Yeah, that is the right one. And now I'm going to type in, what did I get, 0.31? And remember, that's a rounded answer, and look at how close that is to 11. Look at how close that is. If I go back to second quit, I really got 0.31458, 56, 53, 314, 585, 653. So graph trace 0.314, 585. Oh, look at that. It's almost 11 on the nose. So after that point, it'll be above 11, right? Now my other value for y, or excuse me, for my time, was about 2 and 19 hundredths. Now let's see what happens there. 2.19. And look at that. I'm getting close to 11. I'm actually just a hair under. Let me use the unrounded version of it here. It was 2185. 185, 414. Watch how close this is going to be. Okay. 2185, 414 is I think what I said. And look at that. Look at how close that is to 11. It's just, let's see, tenths, hundredths, thousandths, 10,000ths, hundred. It's 100,000th of a foot more than 11. So basically what's happening is it's above 11 feet. It's above 11 feet between this time and this time. Okay? Everywhere else, it's above 11 feet. All right? Okay, so we'll get a little more practice with this kind of stuff on Wednesday. Hopefully you've thought, excuse me, on Thursday. We have a test on Friday. Hopefully you've thought about that bullet question. We'll talk a little bit about it. Let's see if you can solve it. All right, Mr. Lawrence signing off. Have a good night, everybody.